Hi guys, welcome to your last video of Honors Algebra 2, and hopefully this is a review. So this should be stuff that you guys learned in geometry, and it does become important in your next classes next year that you can know these formulas and then apply them to things called series. So we're just going to review this and then you guys are going to go do a maze. So we're going to start with an arithmetic sequence formula. It says the nth term of any arithmetic sequence can be found using the following formula. So the formula is A of n. So that just means the value of any term in that sequence, and n is the term number, is equal to d times n plus a of 0. And then the couple things that you guys need to know of what these are. So your d is the common difference, which is what you are specifically adding or subtracting in between each of your term numbers. And then this a sub 0 is your 0 term. And we always usually have to go backwards to get these terms when we're in a sequence because they usually give us the first. So we do have to go backward to get that 0 term. And then we just find these things, plug them in, then we have a formula. And we can find term numbers. And then the other one is a geometric sequence. So geometric is, instead of having a difference of adding and subtracting, it's when you're multiplying to get in between each of your term numbers. So we're still going to call it a sub n. Sometimes I like to write this as g of n for geometric, but just for sake of making sense for the worksheet, we'll call it a of n equals, and then this one is a sub 0 times r raised to the n. So the n is your exponent. So think about this one being like, if you're multiplying, it's really like this, y equals ab to the x, like your exponential equation, okay? And then again, your a sub 0 here is the 0 term, and they usually give you the first, so you just have to be careful. And then your R value here, ooh, that was really thick. Let's not use that. And then this R value here, they call the common ratio. And that's just what you are using to multiply to get in between each of your numbers. So it's whatever your multiplier is, okay? So what we're gonna do is we're gonna walk through some examples and then you guys are gonna go do that maze worksheet, okay? So it says, write the formula for the arithmetic sequence and then find a sub 16, so the 16th term. So the first thing you guys have to do is just figure out how do you move from one term to the next. So to go from 7 to 4, 4 to 1, I can see that I'm subtracting 3 over and over again, okay? And then remember, this is the first term, second term, third term, fourth term, etc. So to write our formula, we have to go backwards to the 0 term. So to go backwards, we have to do the opposite operation. So instead of subtracting 3, we add 3. So then this becomes 10. So in this problem, we know that our a sub 0 is 10 and that our common difference is minus 3 because we're subtracting 3 over and over again, all right? So then we can just write the formula. So we can say a, oh, that's really skinny now. A sub n equals, and then we go up to the formula above. So our common difference was negative 3. Our variable is n because that's our term number, plus our 0 term, which is 10. So that's our formula. And then we want to find a sub 16. So that seriously just means anywhere you see an n, you're plugging in 16. So I would do negative 3 times 16 plus 10, and this becomes, I think, negative 38. So your 16th term of the sequence, if you kept going, would be 38, and then that would be your guys' final answer to this one. Okay? Next one, it says, write the formula for the arithmetic sequence and then find a sub 22, so the 22nd term. Okay, so this one looks a little complicated. We have to figure out how we're going to get from negative 5/6 to negative 1/2, etc., etc. So let's see. In order to make negative 5/6 become negative 1/2, I know that this numerator would have to be 3, so then 3/6 would be 1/2. So then if I'm at negative 5 and I need it to be at negative 3 to make it negative 1/2, we add 2, and then our denominator has to be 6 so that that stays the same. And then we can just check using our calculator if that actually makes sense and works. So if I do negative 5/6 plus 2/6, I can see that that comes out to be negative 1/2. And then if I do that plus 2/6 again, oops. And then you guys know you can do this whole math frac thing, right? So then I get negative 1/6. So I can see my common ratio is to add 2/6 over and over again. And then remember, this is your first, second, third, fourth term. So we got to go backwards to our 0 term. So we subtract 2/6. So if I'm at 5 and I take away 2, this would be negative 7/6. And you guys can also do that in your calculator if you need to, but you guys are smart enough to do that without. Okay, so then we just write our formula. So we know our a sub 0, our 0 term is -7/6, and our difference is we're adding 2 6 over and over again. So our equation would be a sub n is 2 6 n minus 7 6. And then if we want to find a22, the 22nd term, we just do 2 6 times 22 minus 7 6. And if you plug that into your calculator, you guys will end up with the 22nd term is 37/6. And then that's going to be your final answer for this one. So this is your formula. And it is important that you guys know how to create these formulas and that you're comfortable with that. So that's going to be your formula. And then this is going to be your final answer for that problem. So that'll be what you get to in the maze. Okay, then we got some word problems. So it says Jason is entering a weightlifting contest. Currently, his maximum bench press weight is 105 pounds. If he increases the weight by 7 pounds each week, what is the maximum weight he will be able to bench after 13 weeks? Okay, so they did give us a starting place. They did say that he was starting at, he is currently at 105, and if he increases his weight each week, he wants to know how much it is going to be after 13 weeks. So this is technically week 1 when he's starting, right? So we got to go backwards to get our a sub 0. So let's first know, we know our common difference is that we're adding 7 over and over again. And so if we need to go backwards to our 0 term, our a sub 0 is going to be 105 minus 7, which gives us 98. And then we just write our formula. So we have a of n equals 7n plus 98. And then if I want to know after 13 weeks where he's going to be, you would do 7 times 13 plus 98. And we know the 13th term of the sequence is 189 pounds. So after 13 weeks, you'd be able to lift 189 pounds on his bench press. It is important to realize that this was your starting week. So you're starting at 1 week and you do have to go backwards. So just be careful when you guys do these problems to really think through them. Okay, then we have writing geometric sequences. So it says write a formula for the geometric sequence and then find the 8th term. So we need to figure out, it does tell us it's geometric, so it tells us that we're multiplying in between each of these terms. So we need to figure out what I multiply 1/25 by to get it to be 3/5. Now, if you can reason through that, that's great. Here's an easy way to find your common ratio, is you take the later one. So I'm gonna take my 3/5, which is my later term, and I'm gonna divide it by my 1/25. So on my calculator, and it is real important that you guys do parentheses appropriately here. So I'm gonna do parentheses 3/5 divided by 1/25. And then it'll tell me what I'm multiplying by. So this tells me that I'm going to multiply this by 15 over and over and over again. So then I can check if I do 1/25, so 1 divided by 25, and then times 15, I should get, if I make this a fraction, the 3/5. And then if I multiply by 15 again, I get the 9, etc. So it tells me that my ratio is 15. So this is going to be 15. R is going to be 15. Now, the only other thing we need to remember is how we get the 0 term. Because remember, this is first, second, third, fourth, etc. So we got to go backwards to the 0. So I'm dividing by 15. So if we think through this in terms of like fractions, we're taking 1/25, and we're dividing by 15. So if you guys know these, your fraction rules, you could also use your calculator, but it's the whole, you copy the numerator, change the multiplication, flip your denominator, and then really we're just taking 25 times 15, so then this would be 1/375. And that is gonna be your a sub 0, okay? So now we have all the information to write our formula. Remember, it's really like a y equals ab to the x when we're doing geometric, whereas the other one is more like a line. So we would say a of n equals, the a is our 0 term, so 1/375, times our multiplier, which is our r, is 15 raised to the n. All right, so this is your a sub 0, and this is your r, and they're being multiplied to the n. So that's your guys' formula. And then they did want us to find, which term was it? The 8th term. So now if I want to find the 8th term, a sub 8, we do 1/375 times 15 raised to the 8, and then we would just type that in the calculator over here. So parentheses 1 divided by 375 times 15 raised to the 8. and we get this huge number. So we get a sub 8 equals 6834375. And then that would be your guys' final answer for that one, okay? So it does get pretty big because we're working with exponential equations, so that makes sense. Okay, and then we got two more. So it says information about the geometric sequence is given below. Write a formula for the sequence and then find the indicated part. So we know the first term, so I'm gonna write these as points. The first term is negative 500. And the fourth term is 4, and they want us to find our multiplier, what our r is. So we're going to start by plugging it into this equation. And you do want to start with the x value that is largest. So this is xy, xy. Since this has a larger x value, I'm going to start by writing that point just by plugging it in. So I'm going to do 4 equals ab to the 4. So I'm taking the y value, it's going here, x value going there. And I'm going to write the other one below it. So negative 500 equals ab to the first. And then what you're going to do is you're going to solve this algebraically. So what we can do is we can divide these two equations. When we do that, the a's cancel out. So this becomes 4 over negative 500 equals. Now if I have b to the fourth divided by b to the first, we subtract exponents. This becomes b cubed. And then I can do the cube root of both sides to get that b value or that r value. So then we just have to go over to our calculator over here and we do math cube root, so number 4 of 4 divided by negative 500. And then if I move this out of the way, negative 0.02, which is negative 1/5. So they tell us our r value for this one is negative 1/5. So since that's where it wanted us to stop, you could stop here. So r is negative 1/5, meaning I'm multiplying by negative 1/5 over and over again to get the terms in the sequence. But let's try to write the equation. So you know a of n equals a sub 0 times our r was negative 1/5 to the n. Now we need to find the 0 term. So we do have the first term, so I can take this and I can go backwards to the 0 term. So I know that I'm multiplying by negative 1/5 going forward. So if I take negative 500 and I divide by negative 1/5, then I can get the starting value. So let's see, what does this become? You copy it out, flip it. So negative 500 times this becomes negative 5 over 1. So negative 500 times 5 is 2,500. So our a sub 0 is 2,500. So then your equation would be a of n equals 2,500 negative 1/5 to the n. And then that would be your equation if it was asking for the equation. If it wants just r, you guys would stop there. But you can always check too. So now if I plug in 1 for n here, my answer to this should be negative 500. If I plugged in 4 for n, I should get out 4. So it is a good idea to just check that your equation makes sense and that you know how to do those things. Again, remember you put the highest x value on top here before you do the dividing, and then it should all work out. Okay, last one. I'm hoping this is like a piece of cake because we've done this so many times in geometry and this year. So it says Jennifer bought a new car for $32,000. Each year her car depreciates by 6%. What is the value of her car after 8 years? So you guys know that your starting value, your a sub 0 is 32,000. And then to get your rate, this is one of the ones that's different because you have the percent. So this is one you do 1 plus or minus whatever your percentage rate is as a decimal. You do plus if you're adding and you do minus if you're subtracting. So in this one, we're subtracting. So to get my R for this one, I'm gonna do 1 minus, and then we take our 6%, change it to a decimal, move the decimal over 2 places, so 0.06. So if I take $1 and I take away 6 cents, I'm at 94 cents. So my R value is 0.94. So then I can write my equation, A of n equals, we're starting at 32,000. My multiplier is 0.94 raised to the n. Now, if I want to know how much it is after 8 years, I just plug in 8 right here for n, and then I plug it in my calculator, and we should get that a sub 8, or after 8 years, is $19,506.2. And I think we did talk about this, and you guys hopefully remember that cars are definitely not investments because every year you're lowering your price, and it's not going to be worth as much as when you bought it. So it's definitely not a good investment, but it's a necessity, which kind of sucks. Okay, so then what you guys are going to do is you're going to go do this maze, and you're going to start in this start box right here, and you're going to solve this. You're going to find the 12th term, and it's either going to lead you in one of these 3 directions. So let's say it leads you here, Then you're going to solve this one and figure out what direction it sends you in. And then whenever you get to this end one, you stop. And then when you guys are done, you're just going to upload a picture of all of your work and a picture of this maze showing me the route that you guys took. And then you're done with this assignment. And that's it, guys. Let me know if you need help with anything or if you're confused about anything. Other than that, I hope you guys are having a great day. Bye, guys.